Hello, I'm Dan, and this is Dan Explains. The last year or two, so-called AIs like Stable Diffusion and ChatGPT have been getting a lot of attention because it seems like they can paint better pictures, write better stories, and even score higher on exams than we humans can. But what makes an AI different from a regular computer program? Isn't it just an interface thing? I mean, if we're going to call ChatGPT intelligent because it can answer a lot of questions, shouldn't we consider Google search intelligent as well, because it can find the answer to almost any question we've got somewhere on the internet? What about AI puts intelligence in artificial intelligence? Let me explain. First off, I'd like to mention that this isn't some kind of tutorial video on AI. It's a video to help people who may not have any programming experience understand what AI is and what it isn't. By all means, if you already know, stick around and leave me a comment pointing out any mistakes I've made. With that out of the way, artificial intelligence, which we all like to abbreviate AI, is not just a buzzword to describe programs that can seemingly do things we previously believed only humans can do. It's also not just about learning, which is what machine learning, or ML, is all about, although those two things have a lot of overlap. Contrary to how things are often depicted in the movies, AI is not hardware. It's mostly software. Having the right kind of fast hardware obviously helps, and many AIs have a certain minimum amount of memory and other hardware specs. But for the most part, that hardware is off-the-shelf stuff anyone can buy, or rent when it comes to things like Amazon Web Services. So, if AI is mostly just software, how is it different from programs that run on the same exact hardware performing very similar functions? The fundamental difference is a simple one: how the program was created. Traditional programs are written line by line by a human. The human figures out all of the logic and what should happen at each and every step. AI works a bit differently. Usually the programmer decides what they want the AI to do, and then they create a program that trains the weights of something called an artificial neural network to perform the desired task. I know the phrase artificial neural network sounds complicated, and most we encounter today are, but how they work is actually much simpler than it sounds. Famous last words. They're made up of layers of numbers called artificial neurons that are connected together through mathematical functions. They usually have an input layer and an output layer. The input layer could be a tokenized text input, and the output a grid of numbers representing an image. By tokenized, I mean the text characters are converted to numbers, because you can't just throw a phrase like black cat directly into a series of mathematical functions. In between the input and output layers are so-called hidden layers, where all the magic happens. The programmer decides how many sets of numbers each one of these layers are made of, and what mathematical functions are used to connect one layer to the next. And finally, how many of these layers there will be. Usually the more layers the better, but the more processing power they will take, and the more issues you might have training it. Because, sometimes if you make them too smart, they outsmart the trainer.
I'm sorry, Dave. I'm afraid I can't do that.
These layers of numbers are usually initialized with random values. Altogether, the whole network of numbers is called an artificial neural net, or an ANN. In practice, an ANN is just a complicated set of mathematical functions connected to each other. When they are initialized with random numbers, pretty much no matter what you put into the input layer, you get random junk in the output layer. This is changed using a process known as machine learning, where someone creates a special program that inputs data into the input layer over and over again, all the while making small, often random changes to the sets of numbers that make up the ANN. Then comparing the outputs to see which sets of numbers produce the best result. Then going back and using the best sets of numbers as a starting point for the next round of training. Eventually set up right with good data, the network of numbers gets a set of values that end up producing coherent results. Oftentimes, how the ANN is actually getting the correct result is impossible to figure out by looking at how all the numbers in the layers are weighted and connected together. They're just too complicated. Now, you may ask why this is useful at all. Wouldn't it be easier for a programmer to just make a regular program to perform the task? Wouldn't a purpose-built program be faster anyway? To that I say, yes and Yes. In fact, many times the output from an ANN needs to be cleaned up using conventional programming. The utility of using an ANN is that it can often pick up correlations in the data it was trained on that a human writing a program would miss. Also, some tasks are extremely hard to program in a conventional way. Consider trying to recognize a type of object like a car in an image. The car would be at any angle or at any distance. Writing a program that takes into account all the possible positions and shapes suddenly becomes a much more daunting task than training an ANN to do it. Also notice that training an ANN is a fundamentally different thing than using one to solve problems. So, when you interact with an ANN, odds are it's actually learning nothing from you. So, its ability to learn and remember is very rudimentary, or not there at all. Now, some do learn from us, like when an already trained ANN is augmented slightly to recognize an individual's voice or face, for instance, but it still requires a discrete training step. Now, notice in the last couple of minutes, I haven't been referring to AI, just ANNs. That's because AI is generally not just one ANN. It's actually a mix of traditional program functions assisted by several ANNs. For instance, using AI for self-driving cars requires an ANN to recognize objects, another ANN to decide what it's going to do about these objects, and traditional programming that handles the routing, connects those ANNs together, and allows their outputs to actually control the car. Another example is people who have written programs to connect ChatGPT and Stable Diffusion together, creating an AI that can not only creatively come up with a detailed description of a fictional place it made up, but also paint that place using Stable Diffusion to show it to you. That's something that would be next to impossible to do using traditional programming alone. So, what is an AI? It's traditional functions that leverage artificial neural networks and machine learning to create an adaptable, and yes, sometimes even creative, program. Thank you for watching. If you liked this video, please press the like button. Subscribe to my channel and ding the bell to get notified when I post new videos. Also, please support me on Patreon. Link in the description. The more people who support me, the more time I can dedicate to making videos like this one. So, until next time, have a great week.